So we just finished group by and having last class. Let's do a in-class exercise on using group by and having. It is not so difficult if I told you you need to use group by and having, but it will be more difficult if give you a question you need to figure out you want to do group by and having or not. And remember, the critical point is, do we need to divide things into subgroup, right? That's yes, you do group by, no, then you don't need to. Okay, so let me give you an in-class exercise here. Okay, so this one, I want to retrieve. Okay, so this one asks you get a department name, okay? Remember, department name is not department number. How do you do this, right? Remember, we talk about, if you want to get department number, you need to go to the department table, right? Okay, and I want to see the lowest salary for department is greater than that. So this comparison is for each department, right? So that's why it's a good candidate for group by. And basically, I mean, explicitly, I want to have department name. And I also want to see the lowest salary of that department. Okay, so in this query, right, so you can see, since I need the lowest salary, I need to know for the department what is the lower salary, right? So in this case, you cannot use subquery to do. Remember last class we talked about the subquery can do filtering, but they cannot tell you exactly what is the number in the select clause. It can only do the filtering through subquery. So this is a good candidate to use group by to handle the problem. I'm going to give you 3 minutes on this. Okay, so let's see how to do this. So in this one, we're going to use select from where. And then whether you have where or not, it depends on from. You do join table, then you don't need where, okay? So I'm going to do the traditional way. So I have a department table and employee table. And I want to make department and employee connected by this, indicating employee works for the department. And here I have department name selected, right? So we select department name. You see the department name and lowest salary, so I need a department name. Also, I want to divide them to see for each department name what is the lowest employee salary. So this is the case of group by department name here. Okay, and so when I write down this, some of you may be curious what happened if we have group by something that is not unique, right? So then they will be put in the same group. So for the query processor, the only thing they recognize is whatever you group by. So for example, D name. So this is actually uniquely identify each department, right? So that's actually a good way to do this. Then the query, so somebody give you a query, the query could, for example, if they group by last name, then not this query, something else, right? So you may have people unrelated with the same last name, then you may have those unrelated people aggregated together using aggregation function. So this is the case if you see you want to ask your customer, right? And then, is that the way you want to do? And in the exam, which are what I ask you to do, and you just go ahead to do it. Don't worry about, it makes sense or not. And I think my exam question makes sense for all of them anyway. Yeah. Okay, and actually, maybe it's a reasonable group for last name. People just want to see, for the same last name, how many, for example, how many email you with the same last name, no matter they're in the same family or not, right? So so you never know. But anyway, so whatever they ask, you want to do group by, right? So I ask department name and group by that. The reason I have the join with two tables is just because the name can only coming from department, is not from employee here. And now you see the example using where, right? So you have where and group by that. And after that, you can finish the rest of select, or you can handle this if statement, right? So I want to see the lowest salary, so I can do having, and I want to see the lowest salary is greater than that, right? And go back to select. I need department name and the lowest salary. This is the minimum salary here. Okay, very common mistake. Okay, so it is wrong. Just simply put and minimum salary greater than 50K, things like that. So you cannot do that. You cannot put aggregation function in the where clause directly. So this is the one more time, it tell you how many. So that's whenever you see things like this, you cannot use the subquery to do that anymore. Okay, without this one, you can alternatively do things using subquery. But if you want to see the actual numbers in the select statement in your output, you have to use group by. Okay, and so this is the case, you have to group by the name. Okay, remember this question asks you, give me the department name, right? So since the query asks you the output explicitly, I need a department name as one column. This one must be the name. And remember the rule we have here. So that's actually a very good thing to show that when you do group by, the grouping attributes and select must be consistent. So you have this in here, so you have to group by this. Otherwise, you see, so if we do name here, but you actually did a group by number or something, like name and number, they are consistent, right? So each department has unique number, unique name, so you don't see the problem. But if it's something else, then the information showing here, like the minimum salary, actually produced according to the department name, not something else. That's why they must be consistent. So you have to use the name. You cannot use the number in here. You cannot use the number in here for this specific question. Okay. Okay, so let's try another one. And hopefully after we finish this, you are in a good shape to do aggregation functions in the having clause and how to use group by. Okay, so this question, Okay, so in this query, I need the department that have more than 5 female employee, and I need to see the department number, how many female employees, and for those female employee, what is the average salary? So I'll give you another 3 minutes on this. Okay, so let's see how to do this. So in this case, we actually only need the employee table, right? So when you have a case like this, you don't actually need to using actual additional tables. And if you use more tables, like say, for example, you put join condition correctly, then you take actual time to run the query unnecessarily. So only whenever you write a query, only use the necessary table needed. Okay, so this is the employee table. That's all we need from here. And I want to use a where clause to restrict a female employee. Okay, and then I need to, since my query asks department number, so I will go to by the number here, and I'm going to select the number. Okay, and for each department, I need department number, I need how many female employee. And remember, this part already give you the female employee. So I'm going to do a count, then I'll be able to know how many female employee. And then the average salary, then I'm going to do average salary. Okay. One more thing is more than 5. So I'm going to use having, since this each of the department I count separately, and I count greater than 5. That's it. Okay. Clear. So let's see something interesting. That is, we need to go back to, okay, so finish a summary. Okay, so we go back to the update statement. For this update statement, we already covered, I already covered the insert like this, but I haven't covered since utilize query. So for example, this query inside the insert statement, we see a query. And since we just finished a query, that's the time we be able to add those queries into insert, delete, and update statement. Let's start with the most interesting thing is the select, okay? And the other one is quite simple. And I will show you something and we'll think what can we do to solve problem, okay? So say I have a table here and I create a table. So whenever you do a create table statement, you are going to have a base table in the database, means physically in the disk, something to save in the disk. And that's this what a create table statement can do. And this create table statement have department name, number of employee, and total salary. So in other words, for each department with the name, I want to know how many employees and what is the total salary. And this is pretty much like what we did, right? So, so now you see certain things on purpose why I give you this kind of exercise, right? So you know how to do those kind of things already. But this is a base table. So you have the table physically, you can think about physically we have something saved as a table in the database, and we have the department name, number of employee, total salary here, and we should have different records in the table. And how can we put records in the table? We use insert statement, right? Just same like you can insert into employee, you can do an insert. And of course, it's not convenient. You actually go there to count how many and put the information. Instead, since we already know how to write a query, right? We just did that. Actually, we did average salary rather than the total salary, right? But they are similar, story, right? So similar way to handle things. Since we already know how to do this, let's write a query. And so what happened is you say insert into a table name, and optionally, you can put the schema, means the column name here. Actually, this one I want to put a question mark. I'm going to talk about this very soon. Why in this case we need this, okay? And then you can run a query to populate the table. So when you create, you only have the structure, right? And then after we run the statement, the value will be in, right? Seems like a good solution here. So when we have aggregation functions in the query, okay, two ways you can handle that in this insert statement. One way is you give the schema name, they should be correspondent to what you have in the select. So again, they are matching by position. So you will see a lot of things in database, they are matching by position. So first position, the name, going to go to the department name. Second position, number of employees count, and this is this. So when you have aggregation function, the first way you can handle this type of insert is doing this way, like the way I show. Another way to do is, okay, so if you don't want to put the schema in, you can use as a keyword here, okay? And you can do select the name as department name, this one as that, and as that, and you can insert it into it. Although, this is kind of like quite a popular, just do this way for insert, okay? I remember in exam, you are not restricted to, so if I were you, I'll just remember this. It's probably an easy way to do this. Okay, and so now let's see, this is, everything's correct, right? So syntax wise, and you can, correct, and you can run this, you can produce result, and everything's fine. Okay, but let me give you a scenario, and you will see, oh, there's something additional I need to do to maintain the consistency. And let's see if it makes sense or not. So when I create a table, and it actually doesn't matter when I create a table, I created the tables, right? And then what matters is when I run the insert statement. Say, for example, I run the insert statement yesterday, and after I run, so yesterday, I run the insert statement at 5 a.m., for example. And at that time, I see computer science, I have 30 employees here, and whatever the salary there. And triple E department, I have 40 employees, whatever the salary there, right? So I run this at 5 o'clock. Yesterday, I have this information, so fine, nothing wrong. Okay, and today, let's see what happened today. What happened is today at 10 a.m., okay, and we have a new employee hired to computer science. So we are going to run an insert statement to the employee table, and we're going to add one more employee to computer science. Okay, we can do that, right? So you know how to do this, right? We just add another one because we have new faculty in computer science. Okay, now things become interesting. So if we query the employee table, say after that, let me give like say 10. Okay, so means we definitely will finish the insert, right? And then I'm going to query the employee table, right? So I query the employee. So for this, okay, so when I query the employee table, how many employees I have? Well, actually, I have 31 at this point, right? I have 31 because we just add one, right? Okay, the problem is if at this same time, I query this department info table, I'm going to get 30, right? This is a stored table, right? This is stored in the database already. Nobody touching this. Unless somebody touching this, the values stay the same. And so at 1010, I have 31. When I query employee table, when I query this table, I have 30 employee. So we see the inconsistency in this table and the employee table. So the two tables are inconsistent because this is actually handling derived information coming from the employee table, actually coming from department and employee table together. So this is a similar case as what we do for derived attribute. So at the very beginning of the semester, we have ER diagram, we have derived attributes, right? So that's something actually similar to this, as we have information, they are calculated or derived from something else, like how many employees, right? So that's derived. And if we handle derived information in the base table directly, okay, this is in a separate table, or you just put this one in a existing base table, like department table. No matter what, for derived attributes, if you put in the base table directly, you are going to face the issue of inconsistency in case of updating on the base table, like employee table, right? And so what can we do? So this issue to maintain two base table, this table and employee table, to maintain the consistency, we can use something called a trigger to do that. And that's something we will cover in 174. And that's trigger is a popular way to maintain consistency and specify certain business logic also. Okay, and in this class, what we can we do? So another way to handle the situation, okay, without worry about inconsistency. So in other words, we can make things consistent. What other approach can we use without a trigger? And that is using something called a wheel. And this material is not required in 134. You're going to learn more about that in 174 class, but I'm going to introduce in this because not everyone go to 174. And I feel this is something you need to at least know. There's something called a wheel there, and in case you want to use it, you can learn more in the future. So let's see how to use wheel. Wheel is usually can be used to summarize the things we already have, or can be used to handle things like derived information we have. This is actually also summarize of things we have, right? So how can we do that? And let me show this to you. Okay, so let me talk about wheel here. So what is wheel? View is a virtual table. Okay, so the reason we said it's virtual is because for view, we don't guarantee the view content will save physically in the disk. Okay, so that's why it's a virtual. And the reason we call it table, right? So the whole thing, virtual table, view is virtual table. The reason we call this table is because we can query view exactly the same way as query any base table. So if you say I can do select star from employee, then definitely can do select star from whatever view name there. So we don't do query the same way, just the storage, they are different. Okay. So we can create a wheel, and once we create a wheel, the wheel is automatically consistent with existing table. So DBMS is responsible to maintain the consistency, not the programmer. You don't need to write a trigger. So DBMS will maintain the consistency. As a programmer, you only need to know how to specify the view, then DBMS will do the rest. So for this very same thing, here, okay, like I want to see those information, I'm going to create a view for that. Okay, let me get rid of this. Okay, so I'm going to say I do create view. Okay, so you see the statement is similar. So instead of create table, I say create view, and then I give a name for the view. So for example, like that, okay? And the name of the view cannot be the same as existing view. And the name of the view cannot be the same as existing table. So both table and view, the name must be unique, because when we run query, right, so we say select star from, we can give a view name here. So that's why the view name must be different from any existing table. Okay, so that's a name. You can give any name to view. And after that, you can give the parameter of the view. So this one tell you this virtual table, what is the schema of it. And there are two ways to do this. And I'm going to show you this way. I don't want people to get confused. So I'm going to show you this way to give the column name explicitly in the view definition here. So I'm going to have okay, I run out of space. I'm going to write down here. Right, so I have the 3 columns for my view explicitly with those department name, number of employee, total salary as the name, and then you see ads. Okay, after that, the whole thing from here to here is a query. So that's exactly the same query as what we have here. And so let me write this down. And so we have one more time to go back to see how to do the group by those things, right? So select. Where, right? Okay, so the front part, I take a department table because I need a department name from it. And I take an employee table, okay, because I need to know the total salary of the employee. And then I'm going to join two tables, okay? And I want to select a D name. And this D name going to be called the department name in my view, just because you specified this explicitly already. And I'm going to count how many. And when I do count, this is going to go to here. And then I'm going to do a sum here. Okay, and this is on salary. Right. And then I do a group by and D name. All right. So now you see this whole thing is exactly the same as what we did here. But this one, this whole page is one piece. So we define a view, and in this one, we define a table. Then we use insert statement to insert the data into it. Okay, so this view going to have 3 columns, and that's department name, number of employee, and total salary. Okay, so when we have view definition using aggregation functions, we either put them directly here as the column name, or we can use as keyword. So we say as something, as something. So you must have one of them, one of the way to solve problem just because aggregation functions there. Okay, so they must have a name correspondingly here. So if you don't, if it's difficult for you to know, you just simply follow what I did here. And that's probably the easy way to do this, define the column name in the view. After we define this, we can run query exactly same way as what we run for other table. So for example, I can say select star from that, right? So then it will give you all the information. So now if we go back to the consistency issues, we actually don't have problem anymore. So say we created this wheel yesterday at 5 o'clock. And then today we add one new faculty. So computer science going to CSE become 31 right now. Okay, and then after that you query the wheel, it will directly give you 31. So you never need to worry about whether this wheel is up to date or not. It's always up to date. It's always consistent with the two tables that the wheel is using, right? The wheel is using two tables. Whenever there's any information updated here, the wheel will be reflected directly. So at the same time, you always have update information. And as a programmer, you only need to know how to create this. You don't need to know how to maintain the consistency because the DBMS maintain the consistency. Actually, if you want to know how the wheel get implemented, right? Why the consistency can be maintained, we're going to cover that in 174. So that's for the wheel definition. And you see this number of employee at the beginning of the semester, that's something called the derived attributes in the ER diagram. Now we'll be able to present this in a wheel format. So you can always create this virtual table, this wheel, and have the derived attributes there. And whenever you want to query this derived attribute, you can query the wheel to get it. Okay, but if you want to put the derived attributes into attributes like in the base table, right? So as I mentioned, when we do the mapping, right, two approach, one is in the base table, then we need to use triggers. Another way, we don't put in the base table, we can create a here. At this point, you'll be able to know we can create a wheel and we can reflect that correspondingly. Okay. So now let's see how to do the delete. I already finished them, and this is the things that I haven't done yet. So we can do the where, right? So usually we do direct comparison, but we also can do a where clause. So this is pretty much the same as everything we already seen in the query in the where, right? So you can do a where, and anything legal in the where you can do in the delete also. So here we see DNO in this bag of numbers, right? Sounds familiar? So we can write a query. So query can be within the delete statement. So this way you don't need to manually delete, things one by one. You can delete everything from research department. So this will be, so if people ask you, can you delete all the employee in research department? That's the way to delete everyone in research department. Okay, and then for the update, so we know we can set information directly, we can update them, and we can also run a query to update the values. So here, we can set the salary 10% more, and which salary only when the employee is in research department. So this is all the research department, a bag of numbers, although you only have one number in the bag. And then when that matching this, we have a 10% raise, right? And one thing important, remember, insert, delete, update, they are write operation, means you can change the database value by running this. So if you run this once, they get 10%, and if you run another time, they get another 10%. But if you do query, right? So remember, if we do select statement, select from, this is a read operation. So they only read or present certain information, but the database data, right? So you have things in the database. So the read will not change the values. Okay, so up to this point, actually I finished everything of SQL. So we learned a lot of different queries. And when you have a question in front of you, you want to take a look to see, what is the best way to handle it. Should we use a subquery or just one single block, or just something I need to use group by, and we do need to use having, or we should put the condition in a where. So those things you can evaluate and decide what's the best way. And next class, we're going to move to another chapter.